When we have a product of two loopy functions, we will have to apply integration by parts more than once. So this is a really interesting case. We have already seen that sine x is loopy. Obviously cosine x is also loopy, but even more loopier than everything is e to the x. Because the integral of e to the x dx and the derivative of e to the x, it's e to the x. So if you take it as u or you take it as dv, e to the x will stay e to the x. So sine x and cosine x are loopy twice. So if we don't care about the sine, then it's really twice, and 4 times if we really cares about the plus and minus. Loopy functions are not reducible, obviously, because they are loopy. They stay almost the same, or sine, cosine, cosine, sine. So a product of two loopy functions as e to the x sine x or e to the x cosine x is done by integration by part twice. Let's do such an example. Here is a product of two loopy functions. This is loopy, and this is loopy. So it really doesn't matter which one you take as the u and the dv, but I'm going to take the u to be e to the x. So the differential of u is e to the x dx. And here we have this one. So take the antiderivative and you get that v equals negative cosine x. By the way, we take all the antiderivative with plus c plus 0. We don't need the plus c here. And we get by the setting this one. So it's first the diagonal, okay, from upper left to down right. So it's e to the x times negative cosine x minus the integral of the product of the two on the right. So we get negative cosine x e to the x dx. Minus minus become plus. So now I need to focus on this one. So again, it's a loopy time loopy. And I'm going to do another integration by parts. But now I do care which one is the u and which one is the dv. Because when I started the u was the e to the x, I will be consistent and I will continue now to take u as e to the x. If I would have taken sine x, then now I would have taken cosine x. And I get this as before. And now dv is cosine x dx, so v is just sine of x. Again, the setting, the diagonal. Okay, so I get, just look at the brackets, e to the x sine x minus the integral of sine x e to the x dx. And don't forget to copy the negative e to the x cosine x from before. So now I'm done with integration. Now I'm going to do some algebra. If you look, everything is kind of equal, so I get actually that the integral of e to the x sine x dx equals what? It's equal this part minus the other integral, which is the same. So I get actually the 2 times integral of e to the x sine x dx equals negative e to the x cosine x plus e to the x sine x. So I can solve for my integral. Simplify a little bit, okay, distribute e to the x. And now I can divide everything by 2. And I get my integral of e to the x sine x dx is e to the x times sine x minus cosine x over 2 plus c. Okay, so at some point after you're done, then you add the plus c, but not before, no need. You have to be very careful. When both functions in the product are loopy, each can be chosen to be u or v. But you must be consistent to have the same choice the second time you apply integration by parts. And I will show you this in a second. Let's not do it and let's see what will happen. So let's say that I started first like this, as I did. And now let's say that in the second time I was not really consistent. It means that now I'm going to choose u to be the cosine x and dv to be the e to the x dx. So here's a little surprise. So if you look only on this integral, it's e to the x cosine x plus the integral of e to the x sine x dx. Do you see what happens here? Here I will show you. Those two will cancel out. And what do you get? You get this equality. This equality is right, but there's no way for me to solve my integral by doing so. I got kind of identity. Yes, I know that the integral of e to the x sine x dx equals to itself. I know that. So that's why you really have to be consistent. So you know now that this is wrong. Just be consistent. So integration by part is used for integration of what? So I'm telling you now that I'm going to show you an example of, for example, this case. All inverse trigonometric functions and the function ln of x can be done only by integration by parts. Sometimes, not many times, sometimes only, a product of trigonometric functions. But I want really to focus about the product of functions f and g from two different families, because the majority of integration by parts is this case, and even more when you see that you have to integrate a product of two functions from different family, you always have to think about integration by parts. So let's see. So let's assume that you have to integrate the product of f and g. If fx is loopy, like cosine x sine x e to the x, and gx is x to the power of an integer, it means that the loopy will always stay loopy, but the x to the n can be reduced. Well, it is reducible, so you will take the u to be x to the n. The bad news is that if n is 5, you will have to do integration by parts 5 times, because you will have to reduce every time the power by 1. If one function in the product, like f of x, is cosine x or sine x, which is loopy, and the other one is also loopy, like e to the x, then you have to do twice integration by part, and you have to be consistent with u and v as I showed you. Here is a case of ln of x. Don't forget, I don't know how to find the antiderivative of ln of x. And x to the n, which is reducible, but I really cannot take u to be x to the n because the u has to be ln of x.